The visual abstract is about numerical analysis and thermal voltaic life prediction of solder layer in the silicon-carbide IGBT power model. Silicon-carbide IGBT combined with the excellent performance of silicon-carbide material and IGBT device, so it is of greater significance to study the lifetime of solder layer. Silicon-carbide IGBT model has a complex structure based on several components, so we use a corner of finite element model. The constitutive model of the solder layer and the material parameters are shown below. Figure 4 shows the overall temperature and precise stress distribution of silicon-carbide IGBT. As shown in the figures, the shear stress at the upper surface is higher than that in the down surface. The shear strain in TIM2 is far higher than that in TIM1. There is a significant time lag between the stress history and the environmental temperature history, which may be due to the fact that it takes a little time for the creep strain. As shown 8, the shear stress and shear strain show good periodicity, which is consistent with the temperature cycle. As the temperature cycle increases, the hysteresis curve gradually becomes consistent, that is, the dissipated energy in each cycle reaches a stable state. The creep strain and strain energy density increases gradually with the temperature cycle. The prediction results of the three models are acceptable, so the finite element model-based thermal voltaic life prediction method is feasible.